Question Q is an application or word problem that we will want to solve, or we will be told to solve, using a system of linear equations, and for that matter we'll be asked to arrive at that solution using matrix methods by reducing the corresponding um, matrix. So we have 100 students enrolled in a 1-hour class at Northwest Vista College, and they are paying $86 per hour if they're a resident, and $202 per hour if they're a non-resident. And I've indicated that total number of students here R, the number of resident students, and N, the number of non-resident students. We don't know how many of each, but we do know that adds up to 100. And if you multiply $86 times the number of residents and $202 times the number of non-residents, the total, the sum, is 9,760. So that gives us our two linear equations that we substitute the coefficients into a matrix, for which we substitute coefficients into a matrix. And so we, in this way, writing it this way, we very conveniently have the upper left entry as a 1, which is what we want in that pattern that I recommended, the counterclockwise 1, 0, 1, 0. And so to get a 0 in this entry, we simply multiply the first row by its this number's additive opposite, which is just negative 86, and add the two rows together. Now, negative 86 times 1 is negative 86, times 1 is negative 86, times 100 is 8,600, or 8,600. And we add that to row 2. Negative 86 plus 86 is 0. Negative 86 plus 202 is 116. And negative 8,600 plus 9,760 is 1,160. Well, that the notation for that operation is negative 86 times row 1 plus row 2 goes into row 2. And that row then, that new row, is changes our matrix into 1, 1, 100, and 0, 116, 1,160. And very conveniently, 1,160 is divisible by 116. Question on the exam will have that exact same circumstance, so that you'll have integer answers for the exam question as you will at the end of this question. So, to get a 1 in this entry here, we multiply that row by the reciprocal of this number. So that's 1 over 116 times 116 is 1. And then 1 over 116 times 1,160 is 10, because 1,160 divided by 116 is 10. So that is our new row 2, and the notation is 1 over 116 times row 2 goes into row 2. So now this is our new version of the matrix, and all we have to do now to finish the solution is to knock this entry out, and if we multiply this second row by a negative 1 and add it to that first row, this entry will be unaffected because there is a 0 here, and that's why we want a 0 there, so we can do whatever we want to eliminate this entry. And so we multiply this second row by negative 1. Negative 1 times 0 is 0, negative 1 times 1 is negative 1, and negative 1 times 10 is negative 10. We then add that row, to the first row. So 0 plus 1 is 1, negative 1 plus 1 is 0, and negative 10 plus 100 is 90. And the notation for that is negative row 2 plus row 1 goes into row 1. So our new and final matrix is 1, 0, 90, and 0, 1, 10. So 90 of these students are residents of the district, and 10 are not. Okay, question R asks us to determine the nth term of a sequence, and the first S sub n, and the first four terms of this sequence are e, negative e squared over 2, e cubed over 4, and negative e to the fourth over 8. Now, there's no common difference between these. That means that if we find the difference between these two terms and then subtract it from this term, we will not get this term here. We won't arrive at that term there. And so because there's no common difference, that means this is not an arithmetic sequence. It's a geometric, because those are the only two that we cover in this class. And so the formula for the nth term of a geometric sequence, S sub n, is S sub n equals S sub 1 times r, the common ratio, raised to the n minus 1. Now the difference between this S sub n and this S sub n is this one is enclosed in the brackets, and that tells you that this is the entire sequence, and this, without the brackets, is just a particular element of the sequence. The subscript n tells us whether this is the first, second, third, fourth, etc. So we need this common ratio before we can calculate this nth term. And the common ratio of a geometric sequence is given by the formula S sub n over S sub n minus 1. So these are any two subsequent terms of the sequence. You can choose any two, but to calculate the common ratio, I have chosen e cubed over 4 and as my S sub n, and my S sub n minus 1, the one just before that, I've chosen negative e squared over 2. Well, this is a complex fraction, and the way I've chosen to reduce that is to multiply the numerator by the reciprocal of the denominator. So e cubed over 4 times negative 2 over e squared simplifies as negative e over 2. 2 here cancels with one of the 2's here, and the e cubed over the e squared reduces to just e. So my common ratio r is negative e over 2. So I substitute that into the formula for the nth term. And this is a little bit tricky, and it's much simpler on the final, but let's go ahead and take a look at this. The nth term of the sequence is the first term in the sequence, times the common ratio, which is negative e over 2, raised to the n minus 1. And so here is a set of factorizations. E I write as e over 1, and if you review the rules of exponents, you'll see that I can write this as e to the negative 1 over 1 times e to the n over 1 times negative 1/2. So I've factored the negative 1/2 out, and it's raised to the n minus 1. Now e to the negative 1 is 1 over e, so e times 1 over e cancels multiplicatively. So I'm left with e to the n times negative 1/2 raised to the n minus 1. And for no reason other than I just chose to, I wrote that with the negative 1/2 to the n minus 1 as the first factor of the product times e to the n as the second. Just as legitimate if you had the e to the n in front here. And at this time, as I'm making these videos, I haven't covered sequences. That's going to happen on Tuesday the 30th. But if you have any questions over any other question, if you see this video before that lesson, give me a text, send me a text to 210-464-5781, or you can email me through Canvas or through ACES. So that's everything, and good luck. I'll see you Tuesday and Thursday.